Do a quick video on the Arduino program for the SLK software for the CAN board. I realized that if you've never used it before, this program is meant to be just an example. You may hear my 3D printer running in the background. I'm printing one of the mounts to put one on the bike. But I'm going to try to go through some of the highlights of the program here. I'm not going to go over every little thing in detail. This program is meant to be sort of an example to get the early starters going. It's not meant to be the end-all be-all application. There's going to be a lot of different things people do with this. So, that's the reason it was developed for an Arduino IDE. The reason I did it this way with the ESP is, you get Bluetooth and some Wi-Fi functionality for free just by picking that processor. And it allows for relatively easy. Arduino IDE is not really a complex development thing to set up. It's not as complex as some other stuff, and Arduino is pretty easy to learn and use. Now there are some somewhat more complex things that I'm using in this application to help with some of the efficiency stuff. I'm not going to go too much in detail for that right now. This is going to be kind of a really basic overview. During the last set of changes, one of the things that I did, by the way, the primary INO is this SLK. The sketch is going to be this SLKCAN _sandbox. And this is from the GitHub page. But when you open that, you should get all of these tabs. So you'll get the SLK sandbox, which is like the main one. You'll get a Bluetooth tab. And the Bluetooth tab has all the basic logic that I'm using for Bluetooth in here. So that's basically separating out each section. This is the CAN MCP. This is the MCP 2.5. I think this should be 1.5. Write that real fast. So this is the part that actually talks to the bike. This is what controls the chip that actually communicates with the bike. So this is the CAN bus part. It actually, it follows the CAN standard and allows the levels and all the work to talk to the bike. I won't get too technical about that, but this is the whole logic that works for that. If you have trouble with logging to the SD card, even though there's an SD card section, because of the way the speed is with the code and how to get it in there quickly, there's actually this section right here called in what we call an if-def, which is some code that either gets compiled or doesn't get compiled. But you'll see this stream CAN messages, and if that's enabled, then it runs this section of code here, which will actually write to the SD card or print to the Arduino terminal. If you're using that, it'll just dump it out over the serial port. I prefer using the SD card for logging. I think it's easier to just pop the card out when you're done and plug it into the computer and get your log file. I'll do another video on that process later. But if you're wanting to log and it's not working, you can come here, and sometimes this will be commented out in the examples. And if so, you can just re-enable it here. And then this define has to be set, and it's going to be on the main page. So this stream CAN messages is going to be on the SLKCAN Sandbox page, and this define has to be enabled. And if it's not, usually it'll look like this, where it's just commented out, and you want to remove these two slashes to remove the comment. And that will get that part working. There are two primary tasks in the application, which may be a little different than what you're used to seeing in Arduino. This is a multi-core processor that we're using, and it also has the ability to do multitasking through some of the Arduino libraries, the ESP32 libraries and all. So I have two dedicated tasks here. One is the MCP task for the CAN stuff. The other one is the Bluetooth task. And then under the normal primary loop that you would normally see in Arduino, this is the LED flashing. So it'll flash on and off once a second. So when the board is running normally, you should see that LED flashing on the board. And that's all that happens here. So if you ever see this stop flashing and your code's running, something's not right. So individual setups for each one of these file sections up top, each tab, all the setups for the different hardware are called here. And so if you have, for example, Bluetooth setup or setup CAN, we'll do that as an example here. If you go to the CAN page and you scroll up, you'll see right here, setup CAN, that's that routine. And this is all the setup stuff that would normally be called in an Arduino setup routine. So all of that is here, and this is what is used to get the thing running. Same thing with the SD card. You come over here to SD card. There's a setup section here, and this is all pretty simple SD card write logic. This is all just how to initialize the card. This is the routine that's called the write to the card. This is probably needs a lot more updating because I've done a lot of updates to the code since I've last used this. But this is a define you can enable for simulating. Maybe if you're not connected to the bike, maybe if you're testing away from the bike, that could be useful. This is a terminal screen output code. There's also one of these in the Bluetooth section that you can use, and so you can either print a terminal screen. By terminal screen, I mean something you would use with like Putty, the serial terminal app Putty. And I'll show an example of this in another video at some point. But essentially what this does is it prints the screen over and over again so that you can look at updating values and you can test stuff and see it without having to have like the phone apps connected and all this other, more detailed stuff when all you want to know is if the controller's seeing the right value. So that's what this little page here does. And Bluetooth, CAN setup, SD card setup, some simulation stuff, and terminal. And it breaks each of these sections out into something that's a little more understandable, especially for like configuring the Bluetooth. Let's see. You can see this section here for stream CAN messages. This is just a place that I stuck the normal serial streaming. It's not actually Bluetooth related. You can see that in the comment here. The Bluetooth stream, again, there's an if-def that controls that. So you'd have to have that defined here. And whenever you're streaming, you would use like Bluetooth connection on Windows, and you would look at that. This won't be like RealDash configuration. In the latest example, the RealDash code is commented out because I need to redo this to reflect all the more recent changes and more data being seen in the code. And I need to set up the RealDash stuff from scratch and make a nice good dash, which I haven't done any of that yet. So that needs some work. But this is where that would be happening. And so whenever I was running the code where I was showing like what gear mode we were in and stuff like that on the phone, this is the code that I was using to do that. And then this shows where it's writing that out to the, as if it's, an interesting thing about this is it'll say send CAN message. This is not the same CAN messages from the bike. This is actually where I've just packed a single CAN message here, and RealDash understands the CAN bus. So, you can do all sorts of different stuff there to pack data and send it over. It's probably a little more complex for the purpose of this video, but just so you can see an idea of where some of this stuff is happening, how it's happening. This is the Bluetooth task itself, which gets called, and that gets called from here. When it gets set up, then the system knows to run this task. If you don't really understand the concept of a different task, or multitasking, it's where the processor uses like different time slices of data. So you can, in effect, you can think of it as two things running at the same time. In reality, it's a little more complicated than that, but I won't go into deep embedded programming stuff here. Just for now, the concept of that is basically you can think of it as two things happening at the same time. Let's see, what its other important thing to show here. So, this code is not perfect. The reason I kind of put this together the way it is I really just needed something to test each interface on the board. And I wanted to go ahead and get some of these boards out to the early adopters using this thing because it allows them to, go ahead and start experimenting. They might be able to help out developing something I don't see or haven't gotten around to yet. They may have a different task in mind for what I've been wanting to do myself with the bike. So, I'm really interested to see what everybody comes up with on this part on their own using it. I will focus on this real quick. This is the section here on receive buffer full. This is actually what happens when the CAN message comes in. So this is what CAN message come in start. This is some serial buffering I showed you earlier for writing to either the SD card or the serial port. This basically is just formatting stuff so it can be written. That's where it would write to the SD card. But here's the interesting bit. This switch statement right here, it picks up the ID that came in on the CAN bus message, and it's going to parse the different values out of here. So it'll say, well, if the CAN ID was 19, which happens to be what I think is the BMS data, then it's going to come in here, it'll pull the battery SOC out, it'll read the amps, it'll read the watts, or it'll estimate the watts. Notice that this is amps times 72, and this comment here is that it's based on the rated voltage, so it's likely low. You know, when I measured the battery voltage, I was reading well into the 80s, and on a charged battery, and even as the battery went down, it was still pretty high. So, you know, really, if you wanted a good calculation of watts, you need the battery voltage in amps at any given time. But I haven't been able to find the battery voltage in the data yet. So I'm using the battery rated voltage in the data in this calculation for now. You know, it's a 72 volt battery, so that's what I'm sort of basing that on. It could be better. This section here, 2DO ID, this is where it's reading the odometer and the trip meter, and it's processing that data. I have if you haven't seen the file I shared in the group about the document where I'm updating all of my notes on the CAN messages, it explains why all this is calculated the way it is. So anyway, there's some interesting stuff to see here. This is where it actually does, you know, the meat of the data processing. Now, for those of you who saw my video overlay, and you're wondering, you know, how I did that or how it's coming through with the app, I'm not actually using Bluetooth or a phone or anything in that example. What I did in that example was I'm actually writing to the SD card using this line right here is enabled, this is enabled, and this line in here is enabled. And then it's writing the raw CAN messages, so it's not actually using any of this stuff it's calculating right here. It's taking the raw CAN messages that it gets in here, the timestamp, the ID, all of that. It's building it up to a string here, and then it's storing it to a line by line. Every time a message comes in, it puts a new line in the SD card with the raw information from what that is. And then later I'll do another video on my CAN Finder app, and in that application, what I do is actually read those CAN messages, generate a CSV file of all the data that's in there. In fact, I make some additional calculations very similar to how I do here. And the reason I do it that way is if there's something I don't have in the Arduino programming at the time, if I have the raw CAN data, I can go back, rerun the log calculation offline, not running on the bike, and then recalculate new values from the data without actually having to go out and write and do a new log. So in that video, what I did was I used my CAN Finder app. I have a parse button in the latest version of that app, which generated a CSV file based on the known CAN data that I had. I then took that information and put it into an application called Dashware. You set up a profile all in there, and it'll let you synchronize your raw data to the video feed. So I have a camera that's on my helmet, took the camera from my helmet, the data from the camera on my helmet, synced it using that Dashware app to the data that was on the CSV file that I generated. And then I was able to generate the data overlay using that. So there's other things you could do. You could probably have apps on your cell phone, and you could have the code transmit to that. I know several people want to be able to do seeing the live data on their cell phone, which was one of my goals for the project too. So there's more work to be done there to make that all nice and neat looking. But you can see if that's a thing you want to do, there's already an example in the Bluetooth section here for where to start with that. You know, you could do all your calculations on the CAN page there, and then you come back over here, you can uncomment this, make it all nice and neat to transmit. But you have to spend some time with RealDash, the cell phone app, to set all that up properly so that it shows on a good dash that's there. And it's pretty time consuming, and it's just, right now I've been more focused on getting boards out for people and cleaning up the code a little bit than I have been on trying to completely flesh that out. So I've done enough to know it'll work, but I haven't done enough to fully detail that. So that's a thing that still needs to be done. So for those that are wanting to do that, it's possible, but it's just not fleshed out in a nice fancy UI. I have displayed the battery SOC and some other data on the application, or on a cell phone screen on mine that I went out for a ride for, just to test that it all worked with it riding, and it did, and it was all fine. I just don't have everything, I had some of this stuff that was here showing there. But what I really need to do with RealDash is sit down and actually make a custom dash for this setup, and then once I've done that, make sure all the data gets sent over in a nice, neat way that it can be used, and then have everything tested and logged there, maybe even log against GPS speed and some other things. So anyway, that's just an idea of how all this is laid out, what it does, and what you should expect. If I send a board out to you, generally I'm using this code to test it, but I may have a few things commented out. Sometimes I have the write to SD card commented out when I'm testing the serial section. It just depends on what order I test them in. So that's an idea. Just be aware that that's a thing you might have to do. I showed in another video on downloading what libraries you need to use. You need to have the ESP32 libraries configured in your Arduino setup, and you need to have the MCP2515 library from the Arduino tools manage libraries. Come on. And in this section here, I showed this in the other video, but the MCP2515, you need to have this installed. This will let you actually write the code that does that. So props to the person who wrote that. That actually made doing my project a lot easier, because I didn't have to go back and write all the custom code for the CAN messaging. All I had to do was use that and then modify the sketch to actually do what I needed to do. One note I will say on that, and you'll see a note on this in the code, is that interrupts for me, the Slicker sends out interrupts are a lot of messages. And so what was happening when I tried using an interrupt on the data coming in that has an interrupt pin on the chip, it was actually overwhelming the ESP32, and it was interrupting way too often. And I don't need super time critical stuff for testing this. So what I did was actually, instead of using an interrupt in the main routine task that I have dedicated to this, I just check if the interrupt pin goes low, and then I run the handler code for that for the library. So that's a thing, if you happen to come across that. Again, here's the if-def for the simulation tab. Here's where it actually comes into play. Your sim variables gets ran, and this is not updated to the latest stuff, but it's there. And then what happens is when you define this runs and this doesn't. So just be aware of that if you want to do some testing without being connected to the bike. If you do that, you do need either a 12-volt external source to plug into your board. Be careful that you hook it up the right way, or there's a place where you can add a jumper to the board. And you can look at the schematic. It's pretty obvious on there. I can't remember exactly, but I think it's. I won't suggest a number here because I don't remember it off the top of my head. But there's a jumper that you can set, and whenever you close that jumper, it jumpers the 5 volts on the board that it uses to run everything from. It connects that to the USB 5 volts, and it will allow you to power the board from your PC in order to program it. Now the reason I don't have that set by default is you don't want that jumper in place whenever you go to connect the bike, because then you're going to have, if you have the jumper in place and you accidentally have USB connected, the two 5 volts are going to fight each other. You don't want that to happen. So just remove the jumper if you do that before plugging it into the bike. If you're not using that method to do program testing, then don't worry about it. So, if anyone has any specific questions on this, post it for me in the group. And I'll see what I can do to explain things a little better. Like I said, I'm not going to go into every line of code on this, but just so you have a general idea of how this all, what I'm thinking about when I'm doing this all, how it all works. and that you understand there's different things that can be enabled or disabled on the example that may not all be working at the same time. For the Bluetooth, you may have a streaming, or you may have it set up to talk to RealDash. For the SD card, it may be logging, configured to log. It may not be configured to log. You may have the terminal set up to write to the serial port, or you may have the stream CAN messages set up to write to the serial port. So lots of different things you can do with this example. When I test, though, I test the Bluetooth functionality via talking to Windows. You can write the terminal out there like I showed you a second ago on here. I test that the LED all works like it's supposed to. I test that the CAN interface works by looking at, making sure messages are coming in. I make sure you can, I do a log to an SD card. I plug an SD card and test that it logs there. So I go through all of that process to do all the testing just to make sure that it's all doing what it should whenever the board is completed and finished and all that. So this is, an open source project. I'm selling these at a relatively low price just to get them out there for people to try right now. So, don't think of this as a product you get from Best Buy or whatever. This is very much you're going to have to want to tinker with it a bit to get results right now. Eventually we may all settle on a default program to run that does something specific. But, I kind of get the sense that people who want to mess with this, they all probably have different goals as to what you want to see. Some people want to see the efficiency of their battery. Some people may want to, see something else, or they may want to have it presented in a different way, or they may want to do logs for videos, or, there's lots of different things you could do. And the reason that I did it where it can be programmed in Arduino is to allow people to be able to do that. And I recognize not everybody is going to have who's interested in using one of these, they're not necessarily going to have the skills to do all that. But, most of it's here. It shouldn't be too hard to modify this to what you want to do. I will say one other note, that can be a little more complicated. The ESP32, if you do things wrong and you upset it, for too much interrupts, too much something, you can get some weird debug messages coming out when you're programming. So, just be aware of that. You can get some. It's not as friendly as like an Arduino Uno, so it's a little more capable, but it's also a little more difficult to use in some context. Don't worry about that too much. But
Okay, ask me about it.
Shut up, Google. Be quiet. My Google speaker has decided to start talking on the desk. So I think that's all for now. If you have any specific questions, just let me know and I'll try to get those answered. I may not respond right away with an answer. It may be easier for me to do a video to describe those answers instead, but I hope this is at least somewhat informative, and I will do some other videos later. So do one on the CAN Finder app at some point, and I'll do one probably just on general how to use the SD card log and some other stuff, just some other basics for right now. But that's all for now. Have a good one.